All right, so here we are with 3.12, solving linear systems with substitution. Substitution. Okay, so this is the second method we're learning for solving linear systems, and I'm recording this during the daytime, so if you hear random animals, sorry, I am in the country. Okay, so we're solving linear systems with substitution. So for number one, remember there are three ways to solve linear systems. And now we're taking a look at the second way to solve linear systems. So, what is this? So, number two, substitution. So when you think of like a substitute, you're replacing it, right? You're taking out one item and you're replacing it with another item. Same idea for this. Substitution is when we take one equation. Remember, we are working with two equations. So when you take one equation and you substitute it into the other equation. So that's the whole plan. We're going to take one equation and we're going to substitute it into the other one. And I'll show you what that looks like. All right, so here's our first example for this class activity. Solve the following system using substitution. Remember, if I give you the method, please use the method. All right, so what's the plan? So the plan, one, solve one equation for a variable. Okay, remember when you solve for a variable, you're going to get that variable by itself. So if I take a look at these two equations, excuse me. For these two equations, which one of these is solved for a variable? Pause the video and think about that. Okay, so the equation that is actually solved for a variable is the first one. Because notice y is by itself. This equation is solved for y at the moment. This equation, it's not solved for anything. None of the variables are by themselves. So, for number one, solve the equation for a variable. That's already been done for us. This guy's been solved for a variable. So step two, take that equation and substitute it into the other equation. What is that going to look like? Well, notice, this is saying y equals 3x plus 7. This is also, if you think about it, saying that 3x plus 7 is the same thing as y. So when I look at my equation here, and I rewrite it, 2x minus 5y equals 4. See this y right here? I am going to take this and replace it with 3x plus 7. And that's not going to change my equation at all because, remember, 3x plus 7, it's the same thing as y. These guys are both equal. Y is equal to 3x plus 7. So what I'm going to do is I'm going to take 3x plus 7 and swap it out with where y is. I'm going to substitute it. I'll take out y and replace it, or substitute it, with 3x plus 7. So notice, this is 5 times 3x plus 7, so when I replace it, I need to make sure I use my multiplication symbol, or the parentheses, so that the multiplication is still there. Okay, so notice I have swapped out or substituted y with what it was equal to, 3x plus 7. Oop, there went my phone. Okay, and so notice this. I now have an equation in only one variable. I know how to solve these. See, there's only an x variable. Before, I had an x and a y variable. That was hard to solve. But when I substituted with the other equation, I now have an equation in only one variable, which I know how to solve. All right, so going ahead and solving this, the plan is always to get x by itself, and right now I see x in two places. So I'm going to use the distribution property and multiply out that -5. So then I have 2x minus, so -5 times 3x, -15x, -5 times 7, -35. All right, let's see. How do we get x by itself? We're going to combine the like terms here. So 2x minus 15x is going to be -13x minus 35 equals 4. All right, solving for x. Let's see. Let's get that 35 to the other side. So we'll add 35 to both sides. And we have -13x equals 39. Okay, we need to get x by itself. So solving for x, that -13 is being multiplied to my x, so I'm going to divide by -13. And if I'm correct, that is 3 times 13. Yep, I'm correct. All right, so x equals -3. And that's all well and dandy, but I'm trying to find a coordinate pair. Remember, for systems, our answers are always going to look like, well, not always. Remember, there are a few other options. If they're the same line, there's going to be infinitely many answers because they're overlapping each other. And if they are parallel lines, they're never going to actually meet, so we won't have an intersection. But we're hoping for an intersection of our two lines, which means our answer should end up being a coordinate pair. So we have found the x value of our coordinate pair, -3. So what are we missing? Well, we're missing the y value. How can we find the y value? Well, what did y equal? Remember, y equals 3x plus 7. So the last step is sub your answer into the first equation. So this was our first equation we used. Y equals 3x plus 7. And we're going to take our answer and substitute it in. So x equals -3. Well, where is x in this equation? Right here. We're going to take that out and substitute it with -3. So y equals 3 times -3 is -9 plus 7, which means y equals -2. And remember our final answer, we want a coordinate point. So there we go. That is our answer. So these two lines, they intersect at the point -3, -2. Now I don't know about you guys, but I preferred this method over trying to graph two lines. Graphing two lines, that was a lot of work. But for substitution, it's actually kind of nice. It didn't quite require as much work as graphing two lines. All right, so that was the first example. We have one more example for this class activity. Here we go. Number 4. Solve the following system using substitution. Ooh, the numbers are a bit bigger here. Okay, go ahead, pause the video, see if you can solve these. Okay. So what was our plan? So the first step was solve one equation for a variable. Well, what do you know? Both of these equations are solved for a variable. In fact, they're both actually in the slope-intercept form. If you notice that, y equals mx plus the b value. So we've done that. So the second thing is to take one equation and substitute it into the other. Now, it does not matter for this problem which one I choose to sub in, because they're both solved for a variable. So what I'm going to do, I'll just go and take the first equation, and we're going to sub this one into the other. So let me rewrite the second equation. And we're going to sub this one in for y. Okay, so I said that I'm going to replace y with -500x plus 13,600. And remember, we can do this because y equals that amount. Okay, so we'll substitute that in. So I'm going to need to move my equal sign over. Negative 500x plus 13,600 equals negative 800x plus 16,000. All right. Once again, we have now created an equation in only one variable. So what's our plan? Well, let's get x to one side. Let's see. I'm going to get a different pen color going here. I'm going to add 800 to both sides. And what do I get? I have 300x plus 13,600 equals 16,000. All right, so what should we do next? Well, to get x by itself, we're going to subtract that 13,600 from both sides. And we're left with 300x equals, and punching that out on my calculator, I get 2,400. All right. Ooh, we've almost solved for x. Let's divide by 300 from both sides. And simplifying this, I can cancel those zeros, and then I'm left with x equals 24 divided by 3, which is 8. Now, you might be tempted to stop, but remember, we're searching for a point where these two lines intersect. Our answer, we want it as a coordinate point. So what we found is the x value. So we're going to go ahead and find y. So how do we do that? We'll go back to the first equation we used. So this one right here, the one that we substituted in with. Okay, so that's this one. Y equals negative 500x plus 13,600. So substituting x equals 8 into our equation, we have y equals negative 500 times 8 plus 13,600. What's that going to be? Well, 8 times 5 is going to be 40. Tack on 2 more zeros, so we have negative 4,000 plus 13,600. And adding that together, we have y equals, that should be 13,200. All right, and so that is the y value, or the y value of our coordinate. Oh, I added that wrong. Don't know what I did there. That's supposed to be this, right there, 9,600. All right, let me fix that. 9,600. So that, I didn't even make that big enough. So let me fix this other part here. Thankfully, I have my whiteout handy. And there we go. That is our answer. We have found the coordinate point where these two lines intersect. Okay, so remember, because we have these two equations and they're in two variables, our answer is going to have the two variable part, the x part and the y part. All right, so that was it for the substitution method for solving systems.